Okay guys, welcome back to another video of Dylan Hacks. So on the previous video I took a video using my Xperia 10 Mark II and experimenting with 21:9 aspect ratio. I think it's cool, isn't it? And I got some little some kind of built-in what is called gimbal is stabilizer. Yes, built-in stabilizer. So I'm gonna again take a look at the child memory display, and just complete a simple. This is example code, a very simple code. So it has several features. So here is the GitHub. So say hello. And yeah, it's on the GitHub already. On the previous video I put the link directly to my GitHub, also in this video too. So just available command, we got the LCD in it, initialize the LCD. So let's take a look at it in the code. So I'm not prepared for the video recording on this guy because take a look at the CPU temperature is 71 degrees Celsius. Not good for doing a big workload. So okay, the init part. So you can see I've got a couple of pointers for obviously passing the parameters. So we've got the bus. The bus is the SPI bus that I use. This one is SPI number 3, I believe. And we got this GPIO. This one is for display enabler, I believe this one. So it's keep somewhere is turn the display on. It's not back on, should be turn display on. I remove the on ops function. The next is the timer. The timer is very important because the timer sorry, oops, and I just messed up, oops. So let me deal with the notification first. Do not disturb. Okay, so the timer function is for PWM generators, things and stuff. The display itself required to refresh there's something called COM inversion. So here I've got the datasheet, but it's not everything in the datasheet. But okay, just want you to know that COM inversion is a periodically changing for display updates. So if it's stuck for not sure how long, it can cause the dot to basically turn to dead pixel. So the timer right now I configured to be running at I believe 50 hertz. So okay, yeah, it's 50 hertz. So I got this prescaler divided from 64 megahertz down to 1 kilohertz, and then divided down again by 20 minus 1 to about 50 hertz. So we got the display refresh rate about 50 hertz, not bad at all. And the SPI speed I set to 5 megahertz, so it's not too fast or not too slow. Okay, so the next one is a COM PWM. So this one is a PWM pin for the COM inversion. Next is the CS pin and the LCD on this one. I'm not sure which this one is used for. LCD on, maybe something else. So yeah, the next one is the LCD update. So the update basically pulls all the data from the memory buffer named display buffer, disp buff, and I sent two first bytes. and the very first byte indicate the command, and the next one indicate the what is called, it's called a grid number. It starts from 1 all the way to 240, but it turns out that this display, or maybe my code just playing a little bit weird. I feel like it actually has 242 rows instead of 240, which is weird. Again, it has a lot of weird things happen until I fine tune, but it's not actually fine tuned right now. I'm gonna figure it out later. Okay, so this update part basically uh, push the data from the buffer memory to the display, and we got the buffer clean, set entire thing to 0 by ff, which is on the display is gonna turn the dot off. It's weird that a logic 1 means the dot is off and logic 0 means the dot is on, which is maybe they have some standard format, I don't know, but only just the CS pin, the chip select pin itself is not quite as SPI standard. And okay, the next one is clean. Just issue the clear command. So the display, I'm not sure about the buffer memory on the display will be clean or not, but the the onboard memory of this STM32 will still retain the data until if you run LCD clean, is only just clear, I believe, the internal memory of the display, not the microcontroller. Oh, okay, so the next one is a load full. So as I see here, buffer update. So take one for example. Let's take one of these for example. It's in the core, include image number 1 and number 2. Oh, not this one. So okay, so basically it just take the equivalence bitmap data equivalent at the size of the display and just copy that. You see that mem copy to the display buffer, and the total file size with bitmap size is 12 kilobytes, 12.0 kilobyte, 12,000 bytes. That's a lot. So memcopy seems to done their job, but for some reason it's slower than using a for loop. So I'm gonna do some more implementation on it, because I've been switching from LSB first to MSB first, back and forth, because some kind of SPI stuff that the display takes is very unusual. So I need to switch back and forth and see which one is do the best, and I need to implement sometimes I need to implement my own bit reverse, but the R bit instruction from ARM, it just worked pretty well. Okay, the next one is LCD load part. So the load part is a bit tricky, as it's load a bitmap and is need to be XY coordinate for where to be on the screen, but X chord and bitmap width need to be what is called, I'm not sure, byte aligned. So it's 8 pixel aligned, so every 8 pixel counts as 1 byte. Basically the X coordinate is gonna be between 1 to 50, because 50 times 8 is about 400 obviously. So we just only write 8 pixel, another 8 pixel. It's not gonna be freely move through every pixel. I'm still implementing that feature on here. The load LCD load pix is pretty much the same, I believe, but just add some little things to it. But it's still not working yet. so gonna need a little bit hard work to it. So this quite a bit mathematically. So if you hate math, just watch this video. So I'm gonna teach you a little bit. This is the advantage that I took from my school way back years ago that I'm learning about. I'm not actually knowing the English name of that lesson, but it's like if you have a number sequence, you can plug the number into the equation and you immediately knows that number. Like they have a same interval, or they might share some kind of ratio or something else like that. So I just create this very simple equation to turn the y coordinate plus accounting variables and turn it into something called xy offset. So I'm gonna use that offset for memcopy. So yeah, a lot of so memcopy does not support a dedicated uh, offset, so I need to do it in a pointer way, that I have a pointer address and I just move further. I just walk from the beginning to some place somewhere else, and that's why that is called offset. So I'm doing with the display buffer and the bitmap buffer. And the next one is load picks, that is pretty much the same as the load part, but this one is pixel aligned, not the byte aligned, so it can be everywhere. Oh, it's not focused. Oops, I just zoom in again. Oh, it's not focused. Okay, it's in focus now. So the code, I still need a whole lot more working on it because I got pretty garbage image on the display. The next one is just normal invert, so it takes the buffer and is inverted and put it back, just that. And the fill, just fill the entire buffer with either 0 or 0 by FF. So basically the screen entirely on or off. And the last one is print. So print is has a little bit limit of the limitation that some kind of this char array does always return 4 bytes when used side off, because for some reason I don't know, so I need to specify the side is not similar to the printf. So I want to make it a little more like printf, but I can't right now. Maybe I will have some better idea, and it's not required to plug in the length of the text. So basically just very simple. I implemented the backslash n detection, so it's a new line detection. Here is a new line detection part. Either the, the characters is more than 50 characters, or is detect a backslash in the new line, like this one, it's gonna get into the new line, move the cursor to the next line, things and stuff. Yeah, and I got the font itself that not actually created by me, but I modified to 1D array, so it's easier to use offset. So okay, let's go to the demonstration. Let's see if this guy focus, because I feel nervous about my new phone. So the display is off right now, so I'm gonna press the button, this blue one, user button. Okay, yeah, it's displayed the bitmap correctly. last time I tried to figure it out, but it's just garbage. Next one is the screen filling entire screen. As you can see, there's still some kind of white line to it. I'm not sure what happened. Maybe I'm gonna use the for loop instead of memset later. So let's move to the next one. Okay, so this is just some kind of uh, anime go drawing that I actually draw this one my own. So I'll just show you a little bit on my paper. Okay, so yeah, so she is Gawgura. I'm not sure how to read her name correctly. Gawrgura. So she is a workshop tuber. Just that. Just take my own work and put on my electronic stuff that I also loved. Okay, let's move to the next one. Okay, let's just clear the entire screen. And yeah, the text. So the font is a little bit small because I use a 8x8 font. Actually, it's a 7x8, but maybe I'm gonna craft one my own. And I have a plan to build a Thai font and add support to this guy, but it's gonna stuck at the C language. That how can I get the Thai language as input to the system and then display on the display printed out on the display. But anyway, I might do it later. Just consider that a flex work project still work in progress, and I cannot even make this guy work on the STM8. Okay, go back to our display. Just push a button again. Is invert the display, and without invert back, if I printed it, it's just gonna leave. It's not a bug, but it's some kind of limitation that need to be implemented later. So yeah, cycle through, cycle through. Yeah, sometimes it's buggy, but it's caused by the interrupt and timing stuff and my very stupid bad coding about the interrupt. So okay guys, thank you for watching this video. I hope you enjoy, and pretty much like me that you built this one. I hope you find some interesting thing in electronics, because I want people to play with this thing, and that's why I quit playing Minecraft for about 3 years and I actually want to go back and play it. But right now I'm working on a lot of stuff and I'm preparing myself for university admission, so I'm gonna away from YouTube for a while, so I might come back soon. Thank you guys for watching this video. Thank you again. Goodbye. See you on the next video.